Hello. Yes. So in yesterday class, we have learnt about power rule of differentiation, and today is again the most important discussion about differentiation. We will learn next three rules that will enable us to solve any differentiation basically. Okay. So let us start with today's class. So just for revision, rule number one was differentiation. Rule one. This is the rule one. We learned about d upon dx of we read it as d upon dx of x raised to n. That is differentiation of x raised to n. What is this? Is it power rule? I think the power jump off and it reduces by 1. So x raised to n minus 1. This is rule 1. What about rule 2? If a constant k is in product with x raised to n, you keep the constant as it is and differentiate x raised to n. So differentiation of x raised to n is nothing but n into x raised to n minus 1. Okay. So now today we will learn these three rules. New rule, differentiation d upon dx. Basically d upon dx is called differentiation. So differentiation of k is any constant. So if you have to differentiate and differentiation of constant is 0. So what is rule 3? Rule 3 is nothing but differentiation of any constant is 0. Okay. Next, rule 4. Rule 3 and rule 4 are quite similar, but they have a difference also. Rule 4 is d upon dx of k into x. So when some constant is in product with x, so this x vanishes and the answer is k only. Kx, differentiation of kx is k. Okay. So differentiation of kx will be k. Let us see rule number 5. Rule number 5 is d upon dx of f of x plus g of x. F of x is some function and g of x is some another function. And you have plus or minus in between, either plus or minus. So what you can do, you will separate it, like it will be differentiation of f of x plus or minus differentiation of g of x. So it will be nothing but d upon dx. D upon dx means differentiation of f of x plus or minus d upon dx of g of x. Okay, so if you have plus or minus differentiation, you can differentiation will go inside and it will separately you can differentiate f of x and g of x. Okay, so let us these are all 5 rules basically. Let us see some questions based on this. So, okay, so first is find dy by dx when y equals to. Okay, so part A, my y is equals to x square plus of 3x. Okay, what we learned, let us differentiate both the sides. So, if you differentiate y, differentiation of y is nothing but dy by dx. Yes. And what about right hand side? Differentiation of x square, is it x raised to n? X raised to n is n into x raised to n minus 1, the power rule. So it will be 2x. And then I have plus, so I will write plus as it is and then differentiate 3x. We just learned any constant into x is x vanishes, so it will be 3. Okay, let us do part B. X square is 2x, that's quite obvious, and difference here we learned new. Any constant times x, the differentiation is the constant only, so 3. Let us try, you can try part B. B is y equals to 8x square minus 7. So differentiation of y is dy by dx equals to 8x square. So I think k into x raised to n. So constant will remain as it is, and the differentiation of x square is 2x. And then minus will come as it is, and 7 is a constant, true? So differentiation of 7, differentiation of any constant is 0. So differentiation of this is 0. Basically, so no need to write. What is my final answer? 8 to the 16x, that's it. What about part C? Okay, so let us write part C as, here my y is nothing but 4x square minus of 3x plus of 5. Yeah, let us do differentiation. Or I will give you a moment to try by yourself. You can pause and try it by yourself. Yes, so it is differentiation of y is dy by dx, and this is equals to 4x square. So 4 will remain as it is, and differentiation of constant into some function. So constant remain as it is, and differentiation of x square is 2x. minus 3x. We just learned if you have kx, it is minus 3 only. And what about plus 5? 5 is a constant, so differentiation of constant is 0. We can skip writing it also, no need to write, or if you want, you can write plus 0 also. So that's it. So we have our differentiation, dy by dx is 4 to the 8x minus 3. So I think we used here, we learned differentiation of constant is 0. Here we learned differentiation of kx is k only. Okay, so this is about it. Let us do a word problem based on it, based on differentiation. And here you should be aware with differentiation is nothing but gradient. Differentiation gives you the gradient. So this question requires this concept. This time they have written f of x. So my f of x is how much? 4x square minus 8x plus 3. Yes, this is my f of x. Let us find the gradient of. Okay. So first time they are asking gradient. And what is gradient? How we find gradient of the function? Differentiation is the gradient. Let us differentiate it. F dash x. F dash x is called f dash x equals to, I think this 4 and 2 you can multiply, it will be 8x and a minus 8. That's it. This f dash x, that is differentiation of f of x, is nothing but gradient. Okay. So important point, f dash x is called gradient. Gradient. Okay. This is the gradient. So yes, find the gradient of the y equals to f of x at point x equals to, okay. So we need gradient at this particular point. Okay, we need gradient at this particular point mean 1 comma 2 comma 0. It mean x equals to 1 by 2. What? Gradient at x equals to half. So it will be nothing but let us, so f dash of half. See, f dash x will give you gradient, and you want gradient at x equals to half. So in place of x, I will substitute, we will substitute half. So this is equals to 8 into half, like here, 8 into half minus of 8. That is 8 into half is 4, 4 minus 8 is minus 4. What we learned, gradient at x equals to half is minus 4. Okay, let us do part B, what they are asking in part B. Find the coordinate of the point on the graph y where the gradient is 8. Okay, this time you want x, coordinate of the point, at what point my gradient is 8. This is the quite reverse question, where you want you know my gradient function f dash x, gradient we can get gradient by this one, 8x minus 8, and we know f dash x represent gradient, and this time you want gradient as 8. Gradient is 8. It means in place of f dash x we will substitute 8. So 8 equals to 8x minus 8. That's it. 8x equals to, it will be minus 8, 16. So 8x equals to 16. X equals to what? X equals to 16 by 8. That is 2. It mean graphically, if you wanted to know. So okay, function. If you see my f of x, that is 4x square minus 8x plus 3. My function is a quadratic function. Okay, 4x square minus of 8x plus 3. Yeah, the function is quadratic function, and if you know the graph of quadratic function is something like parabola. Okay, since the coefficient of x square is 4, that is positive, so it will open up, the parabola will be opening up. We got our gradient will be 8 at x equals to 2. Somewhere at this, let us say this is the point A, whose and gradient mean gradient of the tangent basically. So if I draw a tangent to the curve at this particular point, my gradient gradient is represented by m, so m will be 8. Yeah, true. Gradient will be 8 at what particular point? We just got x equals to 2. So the x coordinate of point 2 is 2, but we don't have the y coordinate of point A. And here we can use this way, since point A is lying on this function, this curve, therefore point A definitely should satisfy the condition of curve. Mean you can substitute x equals to 2 in the curve. Why? Because point A is lying on the curve. So therefore to get y coordinate, you can substitute x equals to 2 in the function. So this is how much? My function is y equals to 4x square minus 8x plus 3. Here we will substitute x equals to 2. If I substitute x equals to 2, I will y equals to 4 into 2 square, 4 into 2 square minus 8 into 2 plus of 3. Yeah, This is 2 square, 4 4 just 16, minus 16 plus 3. So what we got? We got y equals to 3. So x equals to 2 and y equals to 3 is the point. So what is your y coordinate? We got y equals to 3. Yes, that's it. In part B, they ask the coordinate of the point. At what point the gradient, and gradient means gradient of the tangent, will be 8. So what we did, f dash x represent a gradient. In place of f dash x, we substituted 8 and we got the gradient. So this is part B. In part C, find the gradient at the point where curve meets the line this. Okay, we find the gradient at the point. We have to find gradient at the point where the curve meets this. Okay, let us first try to find what is a function. We have to find the point where curve meets this line first. Let us try to find the point of intersection of curve and this line. So curve is you can start solving, by the way. You know how to find a point, the point of intersection. Just solve those two equations simultaneously. F of x equals to, so I am solving it here. What is the function? Okay, so it is 4x square minus 8x plus 3. So y equals to 4x square minus 8x plus 3. Yeah, this is the function. Let me check. 4x square minus 8x plus 3. Yes. And what is my y equals to 4x minus 5. Yeah. Y equals to 4x minus 5. I'm solving right now. We are solving part C. Yes. So we have to find point of intersection of these two. Okay. Let us try to find. Since my this is equation number 1, that is parabola, and this is equation number 2, that is line. Definitely you can see the left hand side of both the equations are same. Therefore, right hand side will also be same. Okay. So it will be nothing but 4x square minus of 8x plus 3 equals 4x minus 5. Let us solve it. So this is 4x square minus 8x minus 4x is minus 12x plus 3 plus 5 is plus 8 equals 0. And I think we can take 4 common. So x square minus 3x plus of 2 equals 0. And since 4 is in product, we will shift this side, it will be in division. 0 upon 4 will be 0. So I will be left with x square minus 3x plus 2 equals to 0. Now you need to factorize, you need to know factorizing a quadratic equation. Okay. This is a quadratic equation I am trying to factorize. And by the way, all quadratic equation could not be factorized. We have other method like formula method and completing square. But let us try to factorize. On product I need to, yes, I can write like this, x square minus 2. Okay, if you try to factorize, you will get this 2, x minus 2 times x minus 1. Yes, you will get this one equals 0. So what are my 2x? I got x equals to 1 comma 2. Yes, so what we got, the parabola and the line, they intersect at two different points. Okay, this is point A and this is point B. One x coordinate is 1, I don't know the y coordinate, and similarly x coordinate is similarly 2 here, we don't know the y coordinate. Okay, we got point of intersection and we got 2x. Okay, but in part C, I think they have asked us find the gradient at these 2 points. So do we have our gradient function? F dash x is our gradient function, which gives us the gradient. What is f dash x? 8x minus 8. Yeah. So it is nothing but 8x minus 8. Okay. 8x minus 8. This is the gradient function. So in the question they are asking, if I draw a tangent at this point, what will be the gradient? And if I draw a tangent at this point, what will be the gradient? Okay. Tangent is a line, by the way, which just touches the curve at one point. Okay. So you can see this line is touching at point A and this line is, so we need the gradient of these two lines. For the gradient at point A, x equals to 1, we can clearly see x equals to 1. So we will just find f dash 1 is 8 minus 8, that is 0. By the way, this curve I am just drawing randomly, so this is not satisfying. Otherwise, the gradient of the gradient at A, what we learned, the gradient who is at point A, the gradient m, that will be 0. And by the way, gradient 0 is a vertical line. There is a vertical line, m equals to 0. I am just drawing a random parabola and random line, so I am not, the graph is not very perfect. And next you will calculate f dash of 2, mean gradient at x equals to 2. So 16 minus 8, that is 8. Yeah, correct. So this gradient is m equals to how much? M equals to 8. So we have find the gradient. So one gradient I am getting m equals to 0, and the other gradient I am getting at m equals to 8. Okay, so this is our solution for part C. By the way, yes, let us see the next part, and this is quite easy. This property we have already learned here as property number 5 or rule number 5. If I have y equals to f of x plus minus gx, so if you have plus or minus, you can differentiate separately. So the differentiation of y will be dy by dx. You differentiate f of x, that is f dash x, and plus minus will remain as it is. The differentiation of g of x is g dash x. Like if I give you like this, let my y is 8x cube plus of 4x. Can you give me dy by dx? So if I differentiation of y is dy by dx, and here is plus. There are two functions. This is first function and this is second function. Okay. Since you have plus or minus, you can differentiate it separately. Differentiation of 8x cube will be how much? 8 will remain as it is, and 3 will jump. So 8 3 is 24. You multiply this two, I think. So 24x square. And what about this? Differentiation of 4x will be 4. Okay. Let us do questions based on it. Yes. So yes, you can only try. So I will. You can pause and try finding A, B, C. Yes. So let me solve. Yes, A is my y is 4x cube plus of 2x. So if I differentiate, my difference dy by dx will be differentiation of 4x will be 4 is a constant. It will remain as it is, and differentiation of x cube is 3x square, and plus differentiation of 2x is 2, you know. So this is 12x square and plus of 2. Yeah. What about part B? Part B is y equals to x cube plus of x square minus of x raised to half. Can I write it as root x only? Yes. So differentiation of y will be dy by dx. Differentiation of x cube is 3x square. Since it is plus, so I will write plus here. X square is 2x. And what about differentiation of root x minus? I will keep as it is. And differentiation of root x. Root x is nothing but x raised to half. You can use power rule, but root x is most popular, very frequently used. So we'll learn this as in part 2. We learned the differentiation of root x is 1 upon 2 root x. So that is what I am writing. Differentiation of root x is nothing but 1 upon 2 root x. This is part B. Let us do part C here. Okay, yes. This is y equals to 1 by 3 into x raised to half, that is root x. Let me write just root x, and plus of 4x square. Okay, so for differentiation of y is dy by dx. Constant times some function. So constant remain as it is, and differentiation of root x is nothing but 1 upon 2 root x, and plus of 4x square. 4 will remain as it is, and 2 will jump. So 4 to is 8x. Yeah. So that is equals to 1 upon this 3, and since I have product, I will multiply the denominator. 3 to is 6. This is 6 root x plus of 8x. Okay. This is my dy upon dx. Okay, so this was about example 8. Let us do one more example based on this idea. Okay, so part A is y equals to 1 upon 4 root x. Let us do it this way. So y equals to 1 upon 4, I will, and this is root x. Root x means x raised to half. I am making it to the numerator. This will be x raised to minus half. Yes. If you shift root x was x raised to half, and if I try to shift it in the numerator, it will be x raised to minus half. So my dy by dx this time will be 1 by 4 will remain as it is, constant. And now I will use power rule. So power will minus half will jump off, and the power will decrease by 1. So minus half minus 1. Is it minus 1 upon 4 to the 8 into minus 1 minus half is minus 3 by 2. So x raised to minus 3 by 2. And do we have, yeah, we have it. Yes. So I can write it as 1 by 8 times 1 by 8 upon x raised to, since it is negative power, you can write this way, x raised to 3 by 2, if you want to write it as positive power. So either you can leave your answer here also, or you can leave your answer here also. Okay, what about part B? Part B is nothing but y equals to x cube times 3x plus 1. So let us open the bracket, expand the bracket first. Let us simplify our function. So y is equals to x cube, to expand the bracket, this x cube will get multiplied by both the terms. So it will be x cube into 3x will be 3x raised to 4. X cube and x, the power, and it will be 3x raised to 4. And then again x cube will multiply by, so it will be x cube only. And now I will differentiate. So my dy by dx equals to 3 is a constant, 3 4 is a 12, x raised to 3, and plus differentiation of x cube is as per power rule, this is 3x squared. This is part B. This is part C now. Part C is also quite okay. This is x minus 2 upon of x squared. Okay, here also we will simplify it first. So can I write this way? My y is equals to, since you have this whole division, you can separate it. It means you can write x upon x square minus of 2 upon x square, and that will lead me to x upon x square is 1 upon x minus this is 2 upon x square. Yes, let us do one more thing. So can I write this way? My y is equals to, right now if I see 1 upon x, the power is 1, so 1 upon x, can I write x raised to minus 1 minus, similarly 2 upon x square, 2 into x raised to minus 2. What we did, we x square was in denominator and now x square is in the numerator. So when you do this from numerator to denominator or denominator to numerator, your sign of sign changes. So this is equals to, now let us differentiate. So dy by dx equals x raised to minus 1. We will apply power rule. So power will jump off and it will decrease by 1. So minus 1 minus 1 minus 2 will remain as it is, and this power will jump off. Minus 2 into x raised to minus 2 minus 1, that is minus 3. Yeah. So this is equals to minus 1 into x raised to minus 2 minus, okay, so minus 2 into minus 2, it will be plus 4 into x raised to minus 3. Yes, and I can write this way. This is minus 1 upon, this is x raised to minus 2. Let us bring it to the denominator, so power will be positive. 1 upon x square, and similarly let us do the same thing here. So this is x cube. This is my dy by dx, I think, for the last one, part C. Okay, so basically we learned all the 5 rules of differentiation. Okay, and if you are liking the video, liking the explanation, please consider liking the video and sharing the video. Very thank you. So, yes.